Hi, I am Rick Bonney, Director Emeritus of the Public Engagement and Science Program at the Cornell Lab of Ornithology. This presentation is part of a 10-module training program on developing and implementing citizen science projects for which scientists collaborate with members of the public to address real-world problems. The goal for this program is to introduce fundamental concepts of citizen science in U.S. federal land management agencies, which often use citizen science to manage resources and to engage the public in agency missions. This program was developed by several partners, including staff from the U.S. Forest Service, the National Park Service, the U.S. Fish and Wildlife Service, the Bureau of Land Management, and Schoodic Institute at Acadia National Park.
This is the 7th module in our 10-module series. Module 6 explored the broad topic of collecting and managing citizen science data. This presentation is about using existing projects and platforms to build citizen science efforts to achieve scientific and resource management objectives for parks, forests, grasslands, refuges, or similar lands and waters. It fits within our 10-part series here. 3 takeaways for this module are: first, that developing a citizen science project is easiest if you adopt or adapt an existing project to meet your needs. Second, that project design also can be simplified by using a citizen science platform, which is an online project building tool. And third, that platforms frequently used by federal agencies include eBird, iNaturalist, and Nature's Notebook, all of which offer support for building projects to meet specific data collection needs. Assembling a citizen science project involves many steps. The process involves determining what data your project participants will collect, designing a data collection protocol and data submission mechanism, building a data housing and storage system, and creating a data display mechanism. The process can be simplified, however, by adopting or adapting a citizen science project that already exists, or by using a project design platform to create and maintain a new project. These approaches can save time and money and ensure that the data your project collects will be useful for their intended purpose. Your project goals and objectives will help you choose a sensible approach for obtaining the data that you desire. Perhaps you want to collect data that already are being collected in other locations. For example, if you want to learn more about the birds that inhabit your park or refuge, you might consider engaging your visitors in eBird, a checklist project for which all of the tools that your participants need to submit and examine bird data already are in place. There is no need to develop a bird checklist program from scratch, no matter your location. As another example, you may want to measure the quality of stream water in your forest. In this case, no project would likely be available for immediate adoption. However, many existing water quality projects, such as Alabama Water Watch or the Adventure Scientists' Wild and Scenic Rivers Project, could be adapted for your specific needs, saving you from developing your protocols from a blank slate. In other cases, you will want to collect data that are not being obtained by an existing project or approach, meaning that you will need to develop a novel project. Even in this situation, you might be able to facilitate project design and management by using a citizen science platform, which is an online tool that allows you to build a project by answering questions about your project design and by populating fields that will allow the platform to create and manage the tools that you need to run your project. Hundreds of citizen science projects already exist, and many can be implemented in a variety of settings, either as is or through simple modifications. Consider NestWatch, a Cornell Lab of Ornithology project that collects data about the breeding biology of nesting birds across North America. This project has been adopted by numerous organizations, including the Nestucca Bay National Wildlife Refuge, which hosts 20 nest boxes in varied refuge habitats. Volunteers manage and monitor the boxes and record data including nest site location, habitat, species using the box, and the numbers of eggs, young, and fledglings. Data are submitted through the NestWatch website and are thus entered into the Continental NestWatch database. In this way, refuge staff learn more about the birds nesting on the refuge, including tree and violet-green swallows, mountain bluebirds, and chestnut-backed chickadees, while adding observations to those of other participants across the continent to better understand and manage the impacts of environmental change on bird populations. Another example of a project that can be adopted is the Dragonfly Mercury Project, which monitors mercury pollution in U.S. national parks and other protected areas using dragonfly larvae as biosentinels, that is, organisms that measurably reflect environmental change. Dozens of national parks are implementing the project or have done so in the past. For this project, park staff and local volunteers collect dragonfly larvae from various park locations. Data are gathered about each specimen in the field. Then the collected larvae are preserved and shipped to a U.S. Geological Survey lab, where they are analyzed for mercury. Since 2009, more than 6,000 volunteers have helped to collect dragonfly larvae at more than 140 parks and other protected areas across the United States. The Dragonfly Mercury Project is now the nation's largest assessment of mercury contamination and environmental risk, and more parks and water bodies are added each year. One location that has implemented the Dragonfly Mercury Project is Indiana Dunes National Park, which uses the project to measure water quality in the park so that potential threats to wildlife and humans can be identified. Park staff also use the project to engage volunteers in science and to connect them to the park's natural resources. The volunteers commit to work in small teams for at least one day for up to 5 hours. Wearing waders and nitrile gloves, they use nets to capture dragonfly nymphs longer than 15 millimeters. They identify the nymphs to the family level, measure their length, prepare labels, store the larvae on ice, and complete data sheets. In 2021, the 8th year that the park ran the project, 14 participants spent more than 50 hours in the field. Park researchers determined that the volunteers were 100% accurate in their identifications of the larvae, and that the average concentration of mercury at Indiana Dunes was lower than the average concentration across all other participating parks. Implementing the Dragonfly Mercury Project is easy because the project organizers have produced a detailed, step-by-step protocol implementation plan. Topics include a field sampling guide, identifying dragonfly larvae, learning about mercury, entering and retrieving data, materials for teachers, and more. A link to the plan is included in the resources provided in the toolkit that accompanies this series. Many other citizen science projects also can be adopted for implementation by agency staff. Several directories are available for locating projects that you can use at your park, refuge, or forest. These include the Federal Citizen Science and Crowdsourcing Catalog, SciStarter, and citsci.org. The Federal Citizen Science and Crowdsourcing Catalog lists citizen science projects involving federal government agencies. Projects can be searched by status, whether active or complete, by agency, or by the field of science, that is, animals, archaeology and culture, climate, and weather. The website scistarter.org features a list of thousands of citizen science projects searchable by location, topic, age level, and more. These are generally not projects run by federal agencies, but many of the projects can be implemented on federal lands. In addition, the site has numerous other resources, primarily for people who wish to participate in citizen science. It also markets projects to increase volunteer recruitment and offers a dashboard for participants to track their engagement in multiple citizen science projects. citsci.org is a platform for building and maintaining citizen science projects. However, the website also contains a searchable database of more than 1,000 projects, many of which would be possible to implement on federal lands. Implementing an existing project is almost always easier than developing a new project from scratch, and it enables you to use protocols and data forms that have been tested and revised for ease of use and accuracy in data reporting. You can have confidence that project data sets are well documented and relevant to those who will be using the data. Understand, though, that implementing any project that you discover in any online directory or database still requires addressing each of the steps in this series of presentations and the accompanying toolkit. That is, even when using a well-designed pre-existing project with its own data protocols, forms, and data management and display capabilities, you still need to set goals and objectives for your own implementation of the project. Define your audience, recruit and train participants, provide them with appropriate feedback, and evaluate your outcomes. Additionally, you should reach out to the individuals or groups who created the pre-existing project to gain insights about adapting the project to your specific situation. Several platforms have been developed to collect citizen science data by accepting them directly into a national or international database. Some platforms also can be used to build projects using the platform's online tools. eBird is a platform through which individuals can submit bird checklists that they collect anytime in any location, from their backyards to birding trips around the world. However, eBird also can be used to build customized bird data collection projects, such as the Sagebrush Songbird Survey that took place over 5 years in Washington. Some platforms offer a large degree of customization opportunities and allow projects to be built more quickly and easily than if they were built from scratch. 3 platforms that seem to be most regularly used by federal agencies to develop citizen science projects are iNaturalist, Nature's Notebook, and citsci.org. Let's look at them. iNaturalist is a social network for sharing biodiversity observations and for crowdsourcing identifications. When participants encounter a living or recently living organism, or evidence of a living organism such as tracks, they can use the website to record who they are, what they saw, where they saw it, when they saw it, and evidence, such as a photo or sound recording, of what they saw. If participants use the iNaturalist app, much of the required information, such as time and location, is recorded automatically. A large community of volunteers corrects mistakes, thus monitoring and improving the quality of the data. Because iNaturalist accepts observations made in any location and does not record information about effort, such as how much time was spent searching, it typically supports unstructured surveys, for example, presence-only or species distribution studies. For this reason, iNaturalist is often used to document bioblitzes. One massive iNaturalist-based bioblitz took place on March 28th and 29th, 2014, within the 80,000 acres of the Golden Gate National Parks, which includes the Golden Gate National Recreation Area, Muir Woods National Monument, and Fort Point National Historic Site. The event was a collaboration between the National Park Service, the Golden Gate National Parks Conservancy, the Presidio Trust, and National Geographic. For this event, 9,000 participants documented 2,350 species, which were recorded in the iNaturalist database. Highlights included the first canopy survey of redwoods at Muir Woods, the first park sighting of a climbing salamander in Muir Woods, sightings of great horned spotted, barred, and saw-whet owls, and a mountain lion sighting at Corral de Tierra. These data added tremendously to the park scientists' knowledge of the flora and fauna of the area. More recently, the Bureau of Land Management has set up an iNaturalist page to monitor species in the Santa Rosa and San Jacinto Mountains National Monument, which the BLM manages. Since 2019, more than 2,000 observers have submitted nearly 80,000 observations. Highlights in 2021 included sightings of the federally endangered peninsular bighorn sheep, Abert's towhee, zebra-tailed lizard, and hedgehog cactus, all of which are permanently recorded in the monument's data records. iNaturalist also can be customized to create specialized citizen science projects, saving project developers time and money and allowing them to build their project on a tried and tested web platform. The Tribal Nations Botanical Research Collaborative did just that. This U.S. Forest Service program collects information on traditionally used plants that have cultural, medicinal, or economic values important to tribal communities. Volunteers record observations of plants on a specified list using their mobile phones, and the data are analyzed to shape conservation and land management goals for increased sustainability of these important plants. The project takes place in the Apache Sitgraves, Coconino, Kaibab, and Tonto National Forests. It started in late 2018, and by the end of 2022, more than 1,200 observers had made more than 4,000 observations of 35 species. The project developers built this collaborative on iNaturalist because the platform made developing and managing the project easy, including communicating with participants and building a leaderboard. They also found that it provided data security as well as data quality, because other people in the iNaturalist community help with identifications and flag data quality issues such as incorrect location. The iNaturalist project page highlights many of the projects built on this platform and is well worth exploring. In addition, the iNaturalist website includes a page with detailed information on how to start and run a project. Nature's Notebook, part of the USA National Phenology Network, is a national platform on which volunteer and professional scientists record observations of plant and animal life cycle events, which are known as phenophases. Flowering plant phenophases include bud burst, first flower, last flower, first ripe fruit, and leaf shedding. Animal phenophases include molting, mating, egg laying or birthing, fledging, emergence from hibernation, and migration. Currently, Nature's Notebook includes more than 25,000 active users at more than 18,000 sites and has collected more than 31 million records. The data are used to improve invasive species management, inform the timing of fire, forecast the activity of insect pests, show the timing of food resources for wildlife, and inform the timing of seed harvest. Contributors to Nature's Notebook collect data using standardized protocols for the 1,276 plants and 374 animal species currently on the Nature's Notebook species list. These protocols include a list of questions about the phenology activity occurring on an individual plant or observed in an animal. Each phenophase is defined in detail, and observers answer whether they see the phenophases occurring. They also can answer an optional question about the intensity or degree to which a phenophase is occurring. Observers can enter data either directly into the Nature's Notebook mobile app or with traditional paper data sheets that they then enter into a web browser application. Nature's Notebook has various measures to ensure high-quality data, all of which are freely available for visualization and download on the Nature's Notebook website. Like iNaturalist, users can submit incidental observations to Nature's Notebook, although the platform is designed primarily for repeated long-term observations on the same individual plants or for animals in the same locations. A national coordinating office based at the University of Arizona maintains the platform and assists federal agencies and other organizations in implementing Nature's Notebook according to their scientific, management, or educational objectives. The National Phenology Network also offers a local phenology program infrastructure, which supports federal agencies and other organizations in long-term phenology program planning and offers an online certification course and community of practice for local phenology leaders. The network operates a collaboration specifically for the U.S. Fish and Wildlife Service, which includes help getting started with a local phenology program, a customized refuge dashboard, and a forecast of spring arrival at individual refuges. One example of agency use of Nature's Notebook is a program on Midway Atoll National Wildlife Refuge. This Pacific Island refuge is a globally important seabird conservation site, which is threatened by an invasive species called golden crownbeard. To eradicate this plant, refuge staff needed to understand how quickly the plant grows and moves from one stage to the next. To gather this information, they developed a citizen science project on the Nature's Notebook platform. Volunteer-collected data allowed them to determine that the plants took a minimum of 30 days to go from leaves to seed drop, information that was critical to developing a management plan that is keeping the plant at or below 1% land cover on the refuge. While iNaturalist and Nature's Notebook are excellent tools for building projects based on observations and phenology, some platforms allow a user to build a project with essentially no predefined data structure. One such platform is sitsci.org, which allows users to define what they wish to measure, to document how they measure, and to build customized data sheets for data entry either online or via mobile applications. Like iNaturalist and Nature's Notebook, the sitsci platform also provides data exploration and visualization tools so that project organizers can create their own visualizations of data trends, relationships, and comparisons. Also on the platform are tools for volunteer communications, for bulk uploading legacy data, and for downloading data. Sitsci.org provides a tutorial that walks a user through the project building experience. The user specifies a project title, adds a banner and logo image, then adds the project goal, purposes, and tasks. The project builder has settings for project governance, open or member-based, for data privacy, public or private, and for opt-in integrations with SciStarter and another platform called Zooniverse. The project builder also manages members and creates data sheets for specific protocols that can be text, image, numerical, categorical, or drop-down. When a volunteer enters data onto the sheets, the data are uploaded and shared on the sitsci.org platform. Currently, sitsci.org hosts more than 1,000 cumulative projects, engaging 14,000 volunteers who have collectively amassed over 1.5 million scientific measurements of diverse phenomena. One example of a citizen science project built on the sitsci.org platform is Utah Water Watch, a water quality data collection and education program that seeks to increase awareness about the importance of water quality and to promote stewardship of Utah's aquatic resources. 2 tiers of monitoring offer both beginners and those with a background in environmental monitoring to contribute data. All volunteers attend a workshop, become certified, and then choose a site to monitor once a month for 7 months out of the year, usually from April to October. Volunteers monitor more frequently if desired or if needed to meet specific monitoring objectives. Data are used to track water quality trends and changes over time, and are used for presentations to state and federal agencies, to local communities, and for academic research. Building this project on sitsci.org allowed the project developers to easily create a complex project with the platform's online tools. The platform also allows individuals to view the data with graphs, charts, and maps, and to download raw data. Starting in 2012, Utah Water Watch has trained well over 1,000 volunteers. Another resource for building citizen science projects is Survey 123. While not a full platform, this tool does allow custom building of surveys and web forms. It also allows combining protocols from different programs. Many federally based citizen science projects have employed Survey 123, including 3 projects previously discussed in this series: Alabama Water Watch, Engaging Angler Scientists, and Glacier National Park's Common Loon Project. The Loon Project is designed to enlist the help of park staff and volunteers to improve data accuracy and to increase survey coverage of priority lakes during the common loon breeding season. Volunteers map locations of territories, nests, and nursery areas, and document disturbance behaviors to identify potential factors affecting loon nesting success. Since 2005, park volunteers have spent more than 40,000 hours and completed 2,479 surveys. Project staff used the Survey 123 application so that submitted data are instantly viewable in a loon survey priority web map, which informs the participants about where surveys are needed and helps them determine which survey sites match their interest and ability. Participants also can see immediately how their contributions are making a difference. Note that unlike the other tools described above, using Survey 123 requires a fee. Zooniverse is an excellent tool for building data management projects. It is best suited for projects based on camera traps or other large collections of photos, and for projects that transcribe text from scanned documents or images. It can be used to develop living room projects that are wonderful for engaging participants with mobility issues or who are physically distant from a park or refuge. Few examples of federal agency projects built on the Zooniverse are available, and the potential for building highly useful projects on this platform is tremendous. One project that has successfully used Zooniverse is Fishery, a project of the South Atlantic Fisheries Management Council. For this project, volunteers examine historic photos of dockside fish catches taken prior to the 1990s to document the species and lengths of fish caught during that time period. The data help to explore whether the past decades have shown changes in overall catch composition or the seasonality of catches, and to see whether the size of fish caught over time have changed. This information can be used to inform both historical and current fishery stock assessment. Several other platforms can be used to build citizen science projects. Anecdata is a citizen science platform developed by the Community Lab at the Mount Desert Island Biological Laboratory in Bar Harbor, Maine. Project managers can use it to create projects and to create data sheets for volunteer use. Participants can submit data using the website or mobile app, and anyone can view and download the data. FieldScope creates a digital homepage for contributory projects that facilitates data sheets, data storage, and visualization. To begin using the platform, a meeting with the organization is required to determine project needs. Chronolog involves installing physical infrastructures to allow for crowdsourced photos of a particular location. The tool compiles submissions to create a time-lapse of a standard scene, and is best suited for long-term projects with a permanent location of interest. This platform requires a fee for use. Thank you for joining me today. The goal of this presentation has been to examine projects and platforms that can be adapted or used to build citizen science projects so that you don't need to start your project from scratch. We hope you'll take away 3 ideas. First, that developing a citizen science project is easiest if you adopt or adapt an existing project to meet your needs. Second, that project design also can be simplified by using a citizen science platform. And third, that platforms frequently used by federal agencies include eBird, iNaturalist, and Nature's Notebook, all of which offer support for building projects to meet specific data collection needs. Module 8 will discuss recruiting, training, and engaging project participants once your project is developed. The accompanying Citizen Science Toolkit includes resources to further guide your citizen science efforts. Have a great day.